Joint, sir.
Yeah, that's what. So when it's about the period is about to hit the thief, what a thief will sense is the relative velocity. Okay, so that is 378 in kilometers per hour. So converted meter per second will be 105. What is the next question?
Sir,
Yeah, what is the next question?
that's it, sir.
Okay,
That's all the doubtful ones.
okay. So what they are teaching right now is
Instantaneous velocities.
so it's just 1D motion. So let me consider only straight line motion. Okay, so let me consider a straight road. And let me take a car. Say it's starting with say initial velocity is starting from rest to 0. So here is 10 kilometers per hour. Or we can say at this time, let us say speed is 20 kilometers per hour. Okay, this distance is, suppose this is the origin or x0, this is x1, x2. So average speed, let this be time instant t1. Let it here, let the time be t2, let the initial time be t0. So what for the time interval t0 to t1, I can define average speed. That is the total distance traveled delta x in this time interval t0 to t1 divided by the amount of time it takes to, that is t1 minus t0, because t1 is later time, so t1 will be more. So this is average speed. Instantaneous speed is just defined at all instants. So at this particular time t1, if I have to get the instantaneous speed, I just have to go t1 minus delta and t1 plus delta in the small time interval, say dt, how much the corresponding displacement change, dx. This is instantaneous speed. Is that clear? Average speed is defined over a,
Yes, sir.
your mic might be off.
Yes, sir.
Now, average speed is defined
I
over a
understood. Yeah.
finite time interval delta t. Okay. Instantaneous speed is defined at a time interval dt, which is almost 0. So it is defined at each time. For this thing, we need a
Yeah.
time interval. Could be half an hour or 1 hour, it could be 1 second, half a second, but it's not 0.
Yeah.
Okay. So,
Yes, sir. Yes, sir.
yeah, just a minute. For example, this motion, say this is the origin, and this my x-axis, the body is moving along the x-axis. So T0, T1, T2 does come here and is turning back. Okay. All these things are happening in one line. Just to, for clarity, I'm showing some gap. T3, T4, like that. So for this thing, I can draw a xt curve, how x is changing with time. So initially, at time t equal to t0 or t equal to 0, t0 is same as 0, see, and x0 is also 0. It is here at the origin. At time instant 1, x has increased to x1. And at time instant 2, x has reached the maximum value of x2. After that, it's turning back. Turning back is possible because I'm just going straight. and coming back. At the turning point, the velocity will be 0. Otherwise, the turning will be not realistic. Okay, so at this turning point, after that, at time instant t3, x has actually decreased. X2 is from here to here, and x3 is from here to here. So x3 value is actually less than x2. That's what is shown here. X3 is this much, and x2 is this much. Okay, and x4 is still less than x3 is because, and x4 is same as x1. So x4 is same as x1, which is this value. Okay, and at time instant phi, it has reached the origin here. So time instant t5 is same as x equal to 0. At an instant 6, it has gone on the negative side, so x value is negative, and 7 it has come back to origin again. So time instant t6, it has taken it, gone in the negative direction of the origin, and t7 is again at the origin. Okay, and t8 is on the positive side, greater than x4. T8 is on the positive side, is greater than x4. Okay, so one way to understand the 1D motion is to draw the trajectory, which is the path of the body. The car is actually moving like this. And for the same information, I can transfer to xt curve. This is the xt curve. Okay, so given this also, I can draw the trajectory. Both are possible. From this trajectory, I can get this one, and from this one, I can get the trajectory. Because from this one, I can say x is increasing to x1, next to is the maximum value, and then it's turning back. Okay, or suppose if I squash this curve on the x-axis, I'll get this trajectory. Okay, so average speed is defined between two time intervals. For example, if I take this interval between 1 and 3, I can get an average speed as the corresponding displacement, which is x13 between this point and this point. So this much is x13. That is same as this one. And the corresponding time is t13. So this ratio, x13 by t13, is the average velocity or speed. Okay, we can call it velocity because I'm taking both positive and negative displacement. Okay, that is same as slope of this line. With the right angle triangle, this ratio is nothing but tan of this line, which is the secant. Secant is a line which touches the curve, or you can say cuts the curve at 2 points. Similarly, I can define instantaneous velocity for the same motion that is defined at all instants. So if we take particular instance t1, I just have to take a small dt time at that particular point and the corresponding dx. Dt is always v towards it because time is always increasing. But here in this at a particular point, 1, dx is positive because when dt is increasing, dx is also increasing. When dt is increasing, I'll reach this point. So corresponding to this point, the dx is positive. So instantaneous velocity at point 1. Instantaneous velocity is defined at all points, like point 1 here. But average velocity is defined between two time instants or time interval, 1 and 3.
Yeah. Yes, sir. Yes, sir.
Okay, that is the difference. So that is slope of this line, which is actually, it will become tangent because this secant will touch this curve at only one point because actually
So
this
it will,
dt is almost zero.
uh, the secant intersect the slope at one point accurately.
Yeah, I'll just explain that.
Yeah, okay.
See, even if we take a circle, this is the chord or the secant, right? So when these 2 points come closer and closer, okay, say this final point, this is the final point. So now the secant will become like this. When it becomes here, so in the limiting case, the secant will become, or the chord will become a tangent. Okay, this is the secant which is, suppose this point 3 is coming nearby. So the limit, when it comes very close, this secant will become a tangent. So instantaneous speed or velocity is slope of the tangent at that particular time instant. Secant is average is over a time interval. For that thing, we'll get a secant. Slope of the secant is the average velocity between the two time instances. Instant velocity is defined at all any instant. So that at that particular instant, go and draw a tangent. Slope of that tangent is the instantaneous velocity. And if I take the magnitude of the instantaneous velocity, I get the instantaneous speed. Because the slope can be either positive or negative. So similarly, if you find instantaneous speed at this time instant 3, here, then this is the tangent. So take the slope of this tangent at point 3, that will be negative. So velocity will be negative, but speed is just the magnitude of this one. So for example, velocity could be minus 20 kilometers per hour or say meter per second. Speed will be just 20. So instantaneous speed is defined like the magnitude of the instantaneous velocity. But while doing average, it's not just the magnitude of this one that is defined independently, like distance between the points 1 and 3. So here in this, for average speed, how do you take this total distance traveled from 1 to 3? So that will be from the distance from 1 to 2, and this distance from 2 to 3.
Yeah, okay.
Yeah, if I add this to divide by t1 3, I'll get the average speed. But instantaneous speed, I just, for velocity, I just have to do this final point from the initial point. That is the displacement, right? So this much divided by the time interval will be the average speed. So average speed will always be greater than its average velocity because the
Yeah.
distance is always greater than the displacement.
Okay. Okay, sir.
But instantaneous, that's a completely it's different meaning. You just have to take the drop the sign.
Yeah. dx by dt instantaneous speed, no?
Yeah.
Or delta x by delta t.
For the speed, you just have to do dx by dt without the sign. If it is negative sign means you just have to drop the negative sign.
Okay. Okay, sir.
So analogy, if you want to understand further, suppose I have tests, yours, so you have weekly tests, right? So for
Sir,
example,
what, sir?
no, just to have this understanding of average and instantaneous, I'm see first month, first week, that test I'm getting some mark, say M11. Okay. And then
Okay.
first month, second test I'm getting M12. First month, third test, similarly, first month, fourth test, similarly, second month, first test, first week. So we can have a lot of these things, right? So I can get an average of some few tests to get an understanding of how you are performing. Another thing is I can take this individual marks and get an understanding of how you are performing. So this individual
It
marks,
can be either increasing or decreasing,
yeah,
no?
yeah, that can vary.
Yeah.
So this individual marks are like instantaneous values. So taking an average of few of them is like average values. The advantage average, I just have to look at one number to get an idea of how you're doing. Instantaneous, I just have to look at all the numbers, but that gives more information. Okay,
Yes, sir. Yes, sir.
like instantaneous velocity is defined at all instants, all time instants. Average, if you want to find average between these two, I just have to take what is happening between those two time intervals.
What, sir?
Average means it's just average between average.
Average between
Suppose I want to find average between 1 and T1 and T8. You have to find the total displacement between T1 and T8
T1 and T8
divided by the total. So it does not
time.
depend on how it goes from 1 to 8. It only depends on the end point.
Yeah.
So this graph you're understanding, this diagram you're understanding. See, this actual diagram is I'm moving along the x-axis. So it's like I'm moving like this, and then I'm coming back like this, and then again going like this. Okay, all these things that happen in a single line. But if I draw too close, it's difficult to see, right? So that's why I've given this gap. This gap is not real. Understood, no? This whole
Understood, sir.
this whole bend thing is happening in one single line, like this, like what I shown here. But if I draw it too close, it's not clear to explain. So that's why I've shown a gap here. So this is 1D motion only. Starting from initial point is going here and is turning at this point. At the turning point, the velocity should be 0. Otherwise, it's not realistic. Like car, I'm going say 20 kilometers per hour, and then 30, and then 10, and then 5. At this point, it should become 0. Only then it's possible for me to turn. When after it turns back, it will be -5, -30, like that. Again, at this turning point, it should be 0. -30 here will become -5, and then 0, and then turn back. Is that clear? Like when
Yes, sir.
I'm throwing the ball from the Earth's surface, it'll keep on going up. When it's turning, the velocity has to be 0.
Then it will come down. If, at one point, velocity will be maximum, and at that point, height also will be maximum. Then the height will reduce drastically as well as the velocity. In this concept, they're bringing air resistance too.
Yeah, yeah. That's a different thing. That will come later. So here in this particular thing,
Yeah. I think the formula was h is equal to root over 2g. I think u is equal to root over h by 2g. Yeah. Yes, sir.
uh,
Initial velocity is equal to root over h by
yeah, yeah.
2g.
Don't mug up too many formulas. You just have to get from the uh, three formulas. V equal to U plus AT, AC equal to UT
Yeah,
plus half AT square, V square
yeah.
equal to U square plus 2AS. Okay.
Like this formula, s is equal to ut plus half at square.
Yeah, yeah. Other formulas you can get derived from these three.
Yeah, kinematic equations.
Yeah. Okay. So here in this case, so okay. Okay. So here in this case, the displacement will be how much? From here to here, I given as L1. It's not undoing. Just a minute. Okay. So from here to this first turning point, the distance is L1. Okay. And from this first turning point, the second turning point, from here to here, the distance is L2. Okay. And from this point to further, the final point, the distance is L3. So how much is the displacement from this initial point to the final point? Give me the answer.
What's it?
I'm starting from this initial point, xi. Okay.
Yes.
And traveling distance L1, then turning back, traveling distance L2, then turning back L2, and then from this point to the final point is L3. So from this initial point I to the final point F, what is the displacement?
Displacement is L1 minus L1 minus L2 plus L3.
Actually, L3 is from here to here. So L1,
No, L1 plus L3.
huh,
L2 will be 0.
No, no, L2 is not 0. L2 is from here to here.
No, like the displacement cancels it out.
Yeah, yeah. Plus L2 and minus L2. Or minus L2 and plus L2. So
Yeah,
in some
that's why
sense, I,
it gets.
yeah, some sense displacement, how far is this from this to
But
this?
the distance it is L1 plus 2 L2 plus L3.
Yeah, L1 plus 2 L2 plus L3. And velocity is displacement by time. It's actually average. L1 plus L3 by the time between 1 and 3 or initial and final. Okay, the corresponding time. And the speed will be distance by the time. So obviously speed will be more than the velocity. Correct? So this turning back and forth, it can happen any number of times. So the most complicated 1D motion is this one only. Just the number of turning back, and this thing I can increase. I can also come back the fully. So is this clear? This is the most complicated 1D motion you can have. All this thing happening on one single straight line. Is it clear?
Yes, sir.
Another complication is one thing is I can go uniform speed and reduce the speed to 0 and then turn back, reduce the speed to 0 again, turn back like this. And how the velocity is changing, whether the velocity can change from this to this like this, or it can change from this to a high speed and then decrease like this. That is one more complication, how fast the velocity is changing. Okay. Other than that, the one dimension cannot be complicated. Okay. Any other, so other problems you can do, right?
No, no, sir. Other than this, no. Mostly all concepts clear only
Okay.
once you have taken to know that.
So these books they gave this year or previously, whatever the books they gave, same thing are using.
This year, this is like 11th they have given.
New books.
Yeah, new books.
Okay, this is a simple question you but already done like this. Can you just read it? Can you just try it? Particle motion is straight in such a way that covers first
Yeah.
half distance in 3 meters per second, next half distance in two equal time intervals with speeds 4.5 and 7.5. Find the average speed of the particle. First thing is to draw a small diagram to understand what's going on. Right?
Is the average speed 4 meter per second, sir?
Okay.
Answer I'm asking.
Yeah, it is 4.
Okay, that was easier than expected.
Okay, this one.
Sir, that question explanation, they given two intervals, sir. So I added both of the, I found average speed for those V1 plus V2 by 2, that formula. Then after finding that average speed, those two halves I combined using the formula 2 V1 V2 divided by V1 plus V2 and got the answer.
I don't like remembering formulas and doing. See, basically, this is the diagram. You should know the distance
Yeah.
is. There are 3 parts to the motion. First part is covering half the distance. And second and third, it's again half. But second part and third part, what is same as the time? The time it will go from
Uh,
here to here is same as time to
yeah.
go from here to here. That's what they're going to the question.
Yeah.
Two equal time intervals, the second part. But the
So
first
for,
the first speed is
so,
4.5. So
yeah.
obviously that's why the distance is less in the second part.
Yeah.
Third part, the time interval is same as the second part, but the speed is high. So that's why the distance covered in 3 is more. Okay. What they're going to say S1 equal to S2 plus S3 and V1 they are
Oh,
given.
okay, that formula. 3 into V1 by V2 plus V3 divided by V by V2 plus V2 V3 plus V1 V3. That formula.
Hmm. That's what I'm saying. I don't like formulas. You have to understand and do.
Sorry.
Okay, try
Like,
to understand this one. S1 is equal to S1, S2 plus S3, right? That's what they're given. Okay. And T2 equal to T3. That means S2 by V2 equal to S3 by V3. Average speed is the total distance traveled, that is S1 plus S2 plus S3, divided the total time, T1 plus T2 plus T3. Okay. S1 plus S2 plus S3 is same as 2S1 because S2 plus S3 is same as S1. And T1 I can write in terms of the distance S1 by the velocity 3, and then T2 is S2 by 4.5, and T3 is S3 by 7.5. And T2 equal to T3, so from that I get the relation between S2 and S3. So I can eliminate everything, bring
if I
everything.
eliminate all the values, we can get by that method also.
Yeah. So I prefer to do it this way rather than remembering the formula.
Next method onwards, I will use this, sir.
Yeah.
So next question onwards, sir.
This one,
Uh, option 2.
you already done this one.
Yeah. The same
Again,
displacement thing.
yeah, again
If we
there's,
find delta S by delta T, sir, well, average velocity.
yeah.
Delta S by
So
delta T, we
the,
find so S1
the
plus S plus.
three intervals have the same distance.
Yeah.
Okay, when the speeds are different. So velocity average is the total displacement, which is S1 plus S2 plus S3, divided the total time. Total displacement is 3D if you assume 1 as 1D. And the time is D by V1. This one,
This one.
again, do from basics, don't use the formula and all.
Okay.
Draw the
Just
diagram.
I'll make the diagram and yeah.
Yeah.
What is the magnitude of average velocity? Symbol, sir.
Average
Displacement,
velocity
right?
is the
Magnitude,
total.
magnitude.
Oh, you got the answer?
No, the magnitude I'm asking. What is the symbol for it, sir?
No, no. What is the velocity average? Average velocity is what? The total displacement divided by the
Yeah.
total time. Okay, so if it comes out to be negative, just have to forget the negative sign. Magnitude of -5 is 5. Magnitude of -2.3 is 2.3. You have to forget the sign, that's all. So the snap which you took today, it's using the which camera? Laptop camera. You
Yes,
might
sir.
the snap you sent today.
Yeah.
That's by using which camera?
Yeah, that's why it's from laptop camera. I did not
Ah,
have my phone
yeah. So for next class,
battery
send
rate.
me the proper snap, okay, using the mobile
Like,
camera.
okay.
Okay, and mark the
The
questions you
battery
want
rate, sir. That's why.
to, yeah, and mark the question you want to discuss.
Okay.
So next class will be on Monday.
Is the answer six, sir? The magnitude of average velocity.
No, do it again. Wrong. He has given the time interval. No, three parts are there. A and B
Yeah.
is fine. You read the full question.
Yeah.
For 0 to 30 minutes, what is the average velocity? Again, for 0 to 50 minutes, you find the average velocity. Again, for 0 to 40 minutes, you find the average velocity. You have to answer A for 1, 2, and 3. So at the end of 30 minutes, you should find the final question, where it will be.
Yeah.
So based on that, you have to get the
Wait,
answer.
wait, wait.
Read the question fully before solving it.
Kilometers per hour. For 30 minutes, he walks with 5 kilometers per hour speed, I think.
No, at the end of 30 minutes, where he'll be. That you have to figure out first.
And it's the answer 5 kilometers per hour, 0 to 30 minutes.
See, time taken to the man to go from home to market is half an hour. So at the end of
Yeah.
half an hour, he'll be at the market.
He'll be at 5. Yeah. He takes average velocity, he takes is to walk there is 5 kilometers per hour.
Yeah,
Using that logic, yes.
yeah. So average speed is just how to get the distance by the time,
Yeah.
which will be same because there is no turning back. Distance and displacement
Yeah.
difference will come when there is turning back. But
Yeah.
for this part, there is no turning back. It's
Both are going in same direction, so no changes.
yeah. So next from 0 to 50 minutes. So after that 20 minutes is there, no? So in 20 minutes, where would I have reached? For second part,
In
you
50 minutes, no?
50 minutes. So 30 minutes I reach the market. So remaining 20 minutes, where you will be at the end of that 20 minutes after turning back from market. So 7.5 into 20 by 60 R. How much distance is that correspond to?
His average velocity will be
See, for the man to return from market to home, the time is 1/3 hour, which is same as 20 minutes, right? So the
6.25 kilometers per hour.
no,
It's okay. Sorry, I didn't know. Yeah, it's 6 minutes. Small calculation mistake. Is it 6 kilometers per hour?
yeah, displacement is 0 because it's reached home. Okay,
Yeah,
so average velocity is 0,
yeah,
but the average speed will be the distance traveled, which is 2.5 into 2,
which is fine. Wait, that's
uh,
total distance traveled.
5
The
divided by the
answer is 6
time.
kilometers per hour.
Yeah, 6 kilometers per hour.
I got it.
So 40 minutes will be somewhere in between that you have to find out. So
Yeah.
that you continue.
Class.
Yeah, yeah. It's gonna. Okay, I want to say this thing. This is the important diagram which you should have drawn. So
Yeah,
this diagram understood, right? It's a
yeah,
trajectory, and I put
yeah.
double arrow here. Why is that so?
He takes more amount of speed to walk from home, from market to home, than
Speed
from
is
home to
higher, no?
market.
While
Yeah,
going forward, the speed is
5 kilometers,
5.
and while going back, the speed is higher. That's
So
why.
if you draw proper diagrams, it'll be easier.
Yeah, I did.
Just for clarity. And I put H for home and M for market.
Yeah,
Okay. So these are the things you have to do.
I think
Okay.
this question it was in our module. In the module, they have given this
I think
question.
it's there in NCRT.
It's direct NCERT question in this book they have given.
Yeah, I think so.
Yeah. Then a few questions are based on differentiation and integration too.
Okay. So this weekly test is which day? Monday.
Monday, yes.
Okay. So all the best.
Thank you, sir.
It's for 720 marks.
Yeah, yes, sir.
No, what about JEE advanced results? Uh,
JEE advanced. No,
Pallavaram, Pallavaram, what is the highest
uh,
rank?
I think 271 something.
Boy or a girl?
I think boy.
Uh-huh. What about the 10th standard which passed from this?
Yeah, that was from our class, the highest was 485.
No. Your senior, immediate senior.
Yeah, our seniors, 496
Who got it?
out of 500.
Boy, is it?
No, she traveled in my, the Dhaka traveled in my one last year.